Modern-day power systems are moving away from traditional designs comprised of reliable generation sources, connected through transmission and distribution networks. A new topology, comprised of embedded generators and variable renewable sources, is emerging as we target lower emission levels. This transition has given rise to challenges, particularly for protection engineers responsible for the secure and reliable operation of their networks. Fault current magnitudes have decreased and their transient characteristics have changed. Source-to-line impedance ratios have increased, and phase sequence quantities have changed. Furthermore, increased levels of embedded generation have given rise to bidirectional power flows. Traditional protection design and coordination approaches have a number of limitations. They consider pairwise coordination of like relay elements limited to a specific grading path for a particular system configuration and for a limited set of fault types and locations. Furthermore, these approaches consider generic relay models with interpreted settings and investigate the main elements only, assuming supervisory elements and internal logic checks are satisfied. The sophisticated cape protection system models are not simply generic distance and overcurrent models with interpreted settings applied to them. All relay types including distance, differential, current, voltage, negative phase sequence are supported. They contains relay-specific models that capture the actual comparator equations, supervision elements and internal logic. The relay tap settings implemented by the relay manufacturers in the devices are also used to apply settings. Furthermore, the models capture the configuration of utilities protection scheme logic, for example the pilot-assisted elements. The CAPE time-stepped event analysis examines the interval between the fastest protection responsible for clearing the fault, and all backup protection operations. It considers these coordination time intervals for each stage of the fault clearing cycle, not simply at fault inception. The assessment considers all elements on the system that respond to the fault, regardless of type or location. The output from the comprehensive analysis is extensive. CAPE's powerful data management and visualizations tools allow the output to be sliced and diced to identify problematic areas of the network, feeders, relay elements or operating contingencies. The output can also be drilled to show detailed reports for the protection performance during the stage clearance of a particular fault. Specific studies, identifying problems can also be executed in the Timestep Simulator by simply selecting from the output. CAPE's Wide Area Protection Review technology introduces a new paradigm to address the emerging need on modern power systems for efficient and comprehensive protection system performance reviews. It provides the efficiencies necessary to deliver the comprehensive assessments required to ensure secure and reliable operation of today's networks, which are subject to rapid change with the increasing levels of renewable penetration.